Hello, welcome to our first official video for Flipped Learning this year. You will have to take notes while watching this video, so please make sure you have a note page titled 4-Science Investigations out and open so that you can take notes while watching the video. Remember, you can always pause or rewind the video if you didn't quite catch something the first time. Let's begin. Science Investigations, Mrs. Burball, Life Science. Investigations versus experiments. Science is all around us. We have trees, we have bacteria, we have meandering rivers. We even have pollinating insects. Science really is all around us, which means we can gain scientific knowledge all the time. And it's important to remember that when we're gaining our scientific knowledge, it doesn't mean that we're always performing an experiment. Sometimes we can gain scientific knowledge just by investigating the world around us. Let's learn a little bit more about this. Science investigations are where we're gaining knowledge through asking questions, making observations, and making connections. Whereas science experiments are where we're gaining knowledge through experimental design using identified variables. This experimental design process that we're talking about when we're performing an experiment is sometimes called the scientific method, but it's important to remember that the scientific method is not the only way to perform an experiment. In fact, scientists have to be creative in the way that they're designing their experiments in order to fit their needs, and they don't always just use one method. So, the experimental design process, or in our case for today, the scientific method. It begins by defining a problem. This can be done by asking a question or even wondering about something. Next, you need to do some research. You should know a little bit of background information about what you're going to be experimenting about. And you can do this by using appropriate reference materials. Next, we would need to plan the experiment. This starts out by identifying the variables. A variable is anything that can change in an experiment. And it's super important that we identify the independent and dependent variables. Otherwise, it's not considered a valid experiment if we don't have identified variables. The independent variable, or the test variable, is the one variable that changes in the experiment. Everything else has to remain the same. The dependent variable, or the outcome variable, is the result of that test variable being manipulated. Next is the control. The control is what we compare our results to. We need to identify our constants. The constants are the variables that must remain the same in an experiment. Remember, the independent variable, or test variable, is the only variable that changes in an experiment. Everything else must remain constant. Otherwise, it's not a valid experiment. And then lastly, we need to come up with our hypothesis. Based on what we know, we would form a prediction of what would happen between these two variables in a controlled experiment. This hypothesis statement is basically your prediction of what will happen in the experiment. Next is the fun part, where we carry out the investigation or experiment. It's very important that while the experiment is running, that the scientists observe what's going on and collect data. There are two different types of data: qualitative data and quantitative data. Now, these two words sound very similar, so listen closely while I explain them. Qualitative data sounds like the word quality. When we're talking about the quality of something, we're talking about its description. So qualitative data is data that deals with descriptions, such as how it looks, smells, or feels. Quantitative data sounds like the word quantity. And when we're talking about the quantity of something, we're talking about numbers. So quantitative data is data that deals with numbers such as height, weight, length, or amount. And then lastly, the scientist needs to collect this data and organize it in some way, such as tables, charts, or even graphing the data so that it's easier to interpret. Lastly, we're going to draw conclusions. This is where we accept or reject our hypothesis. Now, if you are accepting your hypothesis, you would state that your data from the experiment supports your hypothesis, and therefore you accept your hypothesis. In other words, your hypothesis was correct. If you're rejecting your hypothesis, you would state that your data does not support your hypothesis, in which case you're rejecting your hypothesis and your hypothesis was incorrect. Sometimes you might go back and rewrite your hypothesis and run more experiments using that new hypothesis in order to come up with an answer to your question or problem. And then, of course, we're always going to share our results. We never want to keep our new knowledge to ourselves. We should always be sharing what we have learned. Next, we're going to use the experimental design process, or the scientific method, by looking at Bounty paper towels. So let's take a look at this commercial and then see if we can put it, use this information in the scientific method.
Letting her home be turned into a training facility? This Olympian's mom has been doing it for years. She's got Bounty. In this lab demo, one sheet of new Bounty leaves this surface cleaner than 2 sheets of the leading Ordinary brand. Bounty has trap and lock technology to soak up big spills and lock them in. Let the spills begin. P&G, proud sponsor of the Olympic Games.
All right, so in this Bounty experiment, if we were to take what this commercial states, saying that Bounty paper towels are better at absorbing liquid than the Bargain brand, then we could run an experiment to see if this is actually accurate. To do this, we would start the scientific method by defining the problem. In this case, we're going to ask the question, does Bounty paper towel absorb more liquid than the Bargain brand? Next, we would do some research. Maybe we need to learn a little bit more about what absorption is. It's the process of soaking up something. Well, that makes sense because we're going to test the paper towels to see how much liquid it can soak up. Next, we need to plan the experiment. First, we need to identify the variables. The independent variable, or the test variable, the one thing we're changing in the experiment, is going to be the brand of paper towel. That's the only thing that's going to change. The dependent variable, or the outcome, is going to be the amount of liquid that is absorbed by the paper towels. This is going to depend on the brand of paper towel, so it's dependent on the independent variable. Next, we're going to list the constants. Remember, all other variables need to remain the same, or need to remain constant throughout the experiment. Otherwise, it's not a valid experiment. So our constants would be the size of paper towel. We need to make sure that we're using the same size of paper towel in our Bounty paper towel and our Bargain brand. The amount of liquid that we're using needs to remain constant. We can't use 20 milliliters of liquid for Bounty paper towels and 40 milliliters of liquid for the Bargain brand. Next is the control. The control, remember, is what we compare our results to. In this case, we would probably want to leave the same amount of liquid that we're going to use. We would want to leave that liquid on the table and not absorb it by any paper towels. That way we can compare what the Bounty paper towel and the Bargain brand paper towel absorb. Lastly, our hypothesis. In this case, I used an if-then statement. So if we test the Bounty paper towels versus the Bargain brand paper towels, then Bounty paper towels will absorb more liquid. Now, this is just my own personal prediction. I'm not sure if it's right or not, but I'm excited to test it out. Now we would carry out the experiment, which means we have to collect data. We would maybe want to know the amount of liquid that is absorbed, and we could do this by massing the paper towel both before and after it's absorbed some liquid. This would be considered quantitative data because we're actually going to use a scale and find the mass of the paper towels. We could also take a picture of the liquid that's left behind on the tabletop. This would be considered qualitative data because it's just looking at the description of what's left behind. Lastly, we need to draw some conclusions. We can state that our data supports that Bounty paper towels absorb more liquid than the Bargain brand, and therefore we accept our hypothesis. Now, I didn't actually run this experiment and see if this is true. This was just an example. But if our data didn't support that the Bounty paper towel absorbed more liquid, then I would say that my hypothesis would have to be rejected, in which case I might want to go and redo my hypothesis and run through the experiment a few more times. Of course, we would always want to share our results so that others can learn from what we were experimenting on. Cookie says, thanks for watching. Remember, you may have to pause or even rewind the video while you're watching in order to make sure you... Oh, Cookie, you're too squirmy. We have trees. We have bacteria. We have Oh, wow. You have some water in there?
Yeah, just a little bit.
Okay.
I'm gonna, like, try to bring a container.
Smile, Cookie, you're on camera. Okay, bye.